in question 3, we are told this function f, and it's defined by this. It just means x is a real number and it's more than 0. And we're given the derivative, we're given the f dash x. Now we've got to find the second derivative at x equals 4. So let's start off by finding the second derivative. Now, what I'm gonna quickly do here is I'm gonna rewrite this in the form kx to the n. So this last term here is going to be x to the minus 2. That allows me to differentiate easily. So f dash dash x, well, that's going to be 2x. That's going to go minus 2x to the power of minus 3. Okay, so let's rewrite that because I know I'm going to have to substitute x to be 4. So let's put it back in its fractional form. So it's going to be minus 2 over x to the power of 3. Okay, so when x is 4, so let's write that. So when x equals 4, we are going to get 2 lots of 4 minus 2 over 4 cubed, which is 8 minus 2 over 64, which is 1 over 32. I just squeeze this in. I hope you can still see it at the bottom. If we're taking 1 over 32 away from 8, so we're going to get 7 and 31 over 32. Okay, that's the first bit done. So B, we're given that the f of 3 equals 0. So we have to find this function. So that means we have to integrate it. So let's, I just changed colour to separate these up. So part B. Now we've got it in this form here. So what I'm going to do is integrate this. So f of x is going to be, let's raise the power and divide by the new power. So x to the 3 over 3 minus 2 to the x. Remember, we don't really have to divide by 1 because it doesn't change anything. So this is going to be plus x to the minus 1 divided by minus 1. So let's tidy this up a bit. So we've got x to the 3 over 3 minus 2 to the x. Now this minus is going to mean that this whole term is going to be negative. So it's just going to be that, because we don't need the dividing by 1. Okay, and obviously I should have done this straight away, but we're going to have this constant value appear when we integrate. All right, and we know that this is equal to, well, so let's write this. So when f of 3 is equal to 0, which means basically the function of x, when x is 3, it's all equal to 0. So what we can say is 0 is equal to 3 cubed divided by 3, take away 2 lots of 3, minus 1 over 3 plus c. So we can now use this to find out what this constant value is, and therefore write the expression for function of x. So 27 divided by 3 is 9, take away 6, take away a third of that. Okay, nice and simple. You can do this one in your head. So that's 3. If you take away a third, we're actually going to get 2 and 2/3 plus c is equal to 0, and therefore c is equal to a negative 2 and 2/3. So all that we have to do now to finish part B is write the whole thing out. So therefore the function of x is, let's take this integrated part. So it's x cubed over 3 minus 2x minus, you can write in either form really, let's just leave it like this, and then we're going to take away 2 and 2/3. Okay, so let's move on to part C. So in part C, we're told to prove that f is an increasing function. So if you just remember what this means, so if we have a curve like this, let's get the highlighter. So if we go from this stationary point here this is increasing. The gradient at any point along here would be positive. Likewise here up to this stationary point where the gradient would then turn to 0. So we're trying to prove that this is an increasing function, and to do that we know that the gradient, well, the derivative is going to be more than 0. So that's what we're going to have to try and work out now. So let's write a little statement here. So let's write increasing when the derivative, so f dash x, is greater than 0. And now let's write what the derivative is. So we've got x squared minus 2 plus 1 over x squared is more than 0. Okay, so we're going to try and solve this. This is a pretty nasty one, to be honest. Now you've got a quadratic here. You've got this term and then you've got another term, and you'll see there's nothing common to both terms, and when you see this quadratic you've got to think factorising. So this is pretty nasty, but let's go ahead and try to factorise it. So nothing in common, so let's go for the 2 brackets. Alright, so I might have to relook at this in a different way, but for now let's go with it. So x squared, well that's x times x. Then we normally look at this third term here and say, well, what do we multiply together to make, what are the factors of this? So the only option really we've got here is 1 over x and 1 over x. Now let's have a look. When we actually expand this, that's going to give me x times that. Well, that's just going to give me a 1. Aha, so I can see I can make this now. And that's also going to give me a 1. And if I make them both minuses, I get minus 1 and minus 1, which is the minus 2, and I get this positive term when I multiply those. So there you go. That's it done. So what I could do is I could, and you can see they're both the same bracket, so what I could say is x minus 1 over x squared is more than 0. Okay, so we've got to just prove that this is more than 0 and therefore increasing. If you think about it, it doesn't really matter what x is. When we square it, it's going to be positive, and therefore it's going to be more than 0, and therefore it's going to be increasing. But is there a chance that we can make this equal to 0? Yes, there is. So if x is 1, when x is equal to 1, that would be 1 take away 1, which is 0, and 0 squared is actually 0. So when x is 1, it is not true. Oops, so true. That does say true, you have to take my word for it. But if we say that when x does not equal 1, then it is true. It is true. And it's always going to be positive, therefore bigger than 0, and therefore it is increasing. So therefore it is increasing. Okay, it's a pretty long video, but that's the end of question 3.